The FoxAlien Vasto XXL is the largest model in the Vasto range. It has a working area of 39.37 inches or 1000mm square and is capable of milling wood, plastics and aluminium. It employs linear rails for rigidity and ball screws for accuracy. The axes are driven by NEMA 23 stepper motors. The spindle motor is a 52mm 400-watt brushed unit with an ER11 collet, a maximum measured speed of 9,930 RPM, and its speed is controlled by a knob on the control box. To maximise performance, 65mm and 69mm spindle holders are provided for the installation of either a trim router or a VFD type spindle motor. The work table consists of aluminium and MDF plates with T-slots for work holding. The control electronics are housed in a steel case with a power supply, DM542 stepper motor driver modules, and a control PCB with an 80 mega 328p microcontroller running Gerbil 1.1H firmware. The wiring loom is connected to the control box with GX16 aviation connectors and runs through cable chains to connect to the stepper motors, limit switches and spindle motor. The machine was supplied in 5 large boxes containing the pre-assembled gantry unit, sides, the Z-axis assembly, hardware, tools, clamps, M-mills, a height probe and the software on a USB stick. The machine has a large footprint, so the first task was to build a table. The tabletop was cut from a single sheet of plywood and the frame was constructed from 2x4s which were screwed together. I've been giving you the worst of me. Now you wanna stay the night. Pity how you work hard for me. Why forgetting how to talk? Nah, I don't like no humble beats. Just go and slice it up. Now it's time to marinate. And right after we're done, I like it when you're looking like that. I like it when you check. I like it when you're looking like that. I tried to find out my reaction. I like it when you look like that. Don't wanna watch a bugger with a white mouth. Just like it when you're looking like that. No sweets, no rush, can't my attraction. Don't think twice, I'm here for the moment. No, I like it better. I got church, but it's somewhere better. I'll make it last forever. I've been giving you the worst of me. Now you wanna stay the night. Pity how you work hard for me. Why forgetting how to talk? Now I don't like no humble beats. Just go and suss it up. Now it's time to marinate. And right after we're done, I've been giving you the worst of me. Okay, so that's the assembly completed. Next I'm going to install the USB device driver, then download and install Universal G-Code sender software, which is used to control the machine. Next, the distance between the gantry and the front of the machine was measured, and adjustments made with the stepper motor knobs to make the two sides equal. To establish a connection with the machine, Gerbil was chosen as the firmware option, the COM port was selected, and the connect button was clicked. Then the machine was unlocked and homed to find its initial starting position. Now we can jog the axes. Next, I'm going to set up the height probe in UGS. There are a couple of different methods that we can use. The first is to set up a macro. I pasted in a script that I created earlier. The second method is to use the probe module. To check that the X and Y axes are square, jog to these coordinates, mark the positions, and the two diagonal measurements should be equal. It also forms a 543 right angle triangle, which can be used to check the calibration of the machine. This machine's calibration was okay, but if the measurements are not as expected, then the Gerbil $100, 101 and 102 steps per millimetre firmware settings can be accessed from the machine firmware settings menu, and I would make a copy before making any changes. Next, I installed a small spoilboard, securing it to the table bed with screws and T-nuts. I'm going to level the spoilboard with a 22mm flat end mill, which has a 6mm shaft, and so I've replaced the 1/8 inch ER11 collet with a 6mm collet. Facing toolpath was created in Fusion 360 and sent to the machine with UGS. Okay, so now that's level, we can try one of the example files from the USB stick. I'm going to attach a block of MDF using painter's tape and CA mitre adhesive. Install one of the V-bits supplied with the kit. Use the probe to zero the Z or Z axis. Jog to the starting position. Zero the X and Y axes. Open one of the example files. And send it to the machine. Next, we're going to design a project in Easel, but before we do that, a quick message from today's video sponsor. PCBWay are best known for their high quality, affordable, rapid manufacturing services. They're currently celebrating their 9th anniversary with a promotion offering fantastic savings on PCBs, 3D printing and CNC machining. With PCBs available from $5 for 10 units, assembly from $30 for 20 units, and 50% off CNC machining and 3D printing. CNC machining includes 3, 4 and 5 axis milling with a wide range of materials and finishes. To get a quote, just select the process, select the material and the options. PCBWay is a one-stop shop for your project needs. For more information, check the link in the video description. Next, I'm going to set up Easel. Easel is beginner-friendly web-based CAD, CAM and control software. First, the Windows Easel driver is installed, and then set up a new machine. Select Other third-party machines. The make is FoxAlien. The model is Other. Motion control is X controller or other Gerbil-based controller. Work area X is 1000mm and work area Y is 1000mm. Select New Machine, and then we can check that jogging is working okay. Change the spindle control preference to automatic. Test the spindle. Answer yes to do we have a Z probe. And check that the touch plate thickness is correct. Now we can get started. First, a new project is created. The material type is selected. And then the size. I'm going to use a 2 flute 1/8 inch end mill. The cut settings were changed to manual, and that allows me to enter a custom feed rate, plunge rate, and depth per pass. The maximum spindle speed is 10,000 RPM, The measurement units can be changed if required. To start the design, I'm going to create a square. It can be resized and positioned with the mouse. The aspect ratio is locked. The size entered. The object's position can be changed with the mouse. The origin position is set to the bottom left-hand corner, and its position entered. We can add a corner radius, and then selecting the Cut tab, we can change the cut path to cut outside the shape path, and the cut depth to cut all the way through the material. Easel has automatically enabled material holding tabs. We can select the size and quantity, and also move their position. Next, I'm going to create some text. Select the font. Set the cut depth, this time to 3mm. Text formatting in Easel is a bit limited, so I'm going to copy and paste the text. Now I can edit the text. If more than one object is selected, a set of alignment options appear. First I select Center on Vertical Axis, and then Distribute. But I messed that up, so let's try again. Okay, so I'm happy with that. Now if I select all 4 objects, I can right click and group them together. Now they act like one object. Let's create another square. This time cutting on the shape path, with a depth of 3mm. Setting the size to 135mm. And a corner radius of 3mm. Now if I select all the objects, I can center on vertical axis and center on horizontal axis. I'm just going to resize the text group. And then center again. We can have a look at what we've created in the 3D window. Give this project a name. We can also simulate the job. I'm going to attach the material with painter's tape and CA mitre adhesive, which is a very strong and versatile attachment method. The adhesive is applied to the tape on one side and the activator on the other side. Now we can select Carve and follow the instructions. The Trial Pro version of Easel can also be used to carve 3D STL files. I installed the 65mm spindle holder and then a Makita trim router, set its speed setting to 3.5, which is approximately 18,000 RPM, installed a 4-flute 6mm carbide end mill for the roughing toolpath, and taped down some more scrap pine wood. Then I installed a 2mm diameter tapered ball nose bit for the finishing toolpath. And finally I cut out the carving with a 1/8 of an inch 2-flute compression end mill. Next I designed a dust chute in Fusion 360. It's made from plywood sections which are glued together. The top and bottom are attached with magnets for easy access to the collet. I'm not going to install a skirt on the dust chute because I want to be able to film the end mill, but it should still pick up the majority of the fine dust. All of the parts were glued together, along with the magnets and 2 6mm wooden dowels as location pegs. Now that I've got some dust extraction, it's time to install a full-size spoilboard. First the 4 mounting holes were milled. And then a facing toolpath was used to level the spoilboard. The main purpose for this CNC machine is to cut sheet material, so to try that out I created a step stool design in Fusion 360 using 18mm or 3/4 inch plywood. The plywood was secured to the spoilboard with screws, a 6mm compression end mill was installed, and the router was set to 18,000 RPM. Then I cut through the tabs, squared off the slots with a chisel and glued the pieces together. I wanted a place to store the probe, so I designed a simple holder and cut it from a polyethylene IKEA chopping board using a 1/8 of an inch single flute end mill. Finally, I created a dice pattern which will be cut from 1/4 inch thick aluminium with a 1/8 inch single flute end mill and a conversion sleeve so that it can fit into the Makita collet. I'm using an air blast to clear chips. The aluminium is 6082 T6 which machines easily, and I'm going to attempt to TIG weld the sides together. Okay, so I've had the Vasto XXL now for about 6 months and I'm pretty happy with it. I'm mainly using it for cutting sheet materials for larger projects. It will happily cut wood, plastics, aluminium and other non-ferrous metals. The supplied 400 watt spindle motor is okay to get started, but its performance is limited and the machine really benefits from the installation of a more powerful trim router or VFD type spindle motor. I hope you liked the video. I'll put links to the various Easel and Fusion 360 models in the video description. Thanks for watching and see you again next time.